So guys, welcome back to our class. Next is we have the algorithm optimization. So what do we mean by algorithm optimization? So optimization of algorithms are a class of algorithms that are used to find the best possible solution to a given problem. So from the given definition, so algorithm works in order to find the best possible solution to a given problem. So next, we have the memoization and top-down dynamic programming. So memoization, this is a technique used in dynamic programming to optimize the execution of a function that has repeated and expensive computation. So memoization works from top-down approach, catches the results of function calls, recursive implementation, well suited for problems with a relatively small set of inputs used when the subproblems have overlapping problems. So this is the application of the memoization. So dynamic programming. Dynamic programming help us to optimize solutions to problems by catching values for future use and improve the runtime of recursive algorithm. So dynamic programming used to optimize solutions to problems by catching the values. Tabulation and bottom-up dynamic programming. So what is tabulation? Tabulation is just the same as the memoization, but it is typically implemented using iteration and is well suited for problems that have a large set of inputs. So what do we mean by iteration? So iteration is repeating the same process. So the application of tabulations or bottom-up approach stores the results of subproblems in a table and iterative implementation. Greedy algorithms, design, and application. So how can we use the greedy algorithm, design, and application? So what is greedy algorithm? A greedy algorithm is an approach to solving a problem that selects the most appropriate option based on the current situation. You can implement a greedy solution only if the problem statement follows two properties. So we have this two property, which is the greedy choice property and optimal substructure. Choosing the in greedy choice property, we need to choose the best option at each phase, which lead us to an overall optimal solution. And optimal substructure is an optimal solution to the complete problem, contains the optimal solution to the subproblems, and the problem has optimal substructure. So from our previous lesson, we learned what greedy and optimal substructure is. So the time complexity and space complexity. In time complexity of an algorithm, it quantifies the amount of time taken by an algorithm to run a function of the length of the output. And in space complexity, it is the amount of memory required by the algorithm to solve given problem, as it requires memory to hold temporary data or final result while the program is executed. We can find this time complexity in our code. Lastly, we have the benchmarking and analyzing algorithm performance. So benchmarking algorithm, it allows you to compare the performance of different algorithms in specific tasks or data sets, enabling us to make informed decision about which algorithm to use in a given context. Analyzing algorithm. It is the determination of the amount of time and space resources required to execute it. Usually, the efficiency of running time of an algorithm is stated as a function relating the input length to the number of steps, known as the time complexity, or value of memory, known as space complexity. In analyzing algorithm, we have the two properties, which is the time complexity and space complexity. So that's all for our topic.